Alrighty, welcome to Chapter 2. The objective for Chapter 2 will be, we will find whole number quotients of whole numbers with up to 4-digit dividends and 2-digit divisors, using strategies based on place value, the properties of operations, and or the relationship between multiplication and division. We will illustrate and explain the calculation using equations, rectangular arrays, and or area models. So this is the bulk of this chapter. However, if you look at what I have highlighted, most of this standard is a review of 4th grade. The only thing that's different between the 4th grade standard and this standard, which is 5th grade, is this little phrase right here, and 2-digit divisors. In 4th grade, they divided with 1-digit divisors. In 5th grade, we expect them to expand on that and do 2-digit divisors. So before we begin, we're going to set up our notebook, of course, and we're going to title this one, Ways to Divide. Of course, you want to have the title on top of your notes, and then, of course, in your table of contents. Before we show some of those ways to divide, today we're going to go over 5 main ways to divide. We're going to look at the definitions for division, just so that we have a clear understanding of what each one of those there's lots of key words in the objective. We want to make sure we understand what those words mean. So the first one is dividend. The dividend is the total amount that is being divided. The total amount that is being divided. That's the dividend. It's what you are breaking up into equal groups. The next one is divisor, because that's the big one. That's the one that changed. We have 2-digit divisors. So what's a divisor? Divisor is how many groups. So how many groups are we splitting up our dividend? And you can also think of that as what you are dividing by. Okay. The next one is quotient, because sometimes you'll get asked in a word problem, what's the quotient? If you see quotient, then you should be ding ding ding, it's division. It's how many things in the group. So the quotient is how many things in the group. Or you can think of it as the answer to the division problem. Okay? And then the last one is the remainder. Now this standard doesn't really talk about remainders. We have we'll have a standard that we do talk about remainders with, but the remainder is what is left over. And we are going to learn a few new things to do with remainders. So there's our definitions of some key words. Now let's look at some of those ways to divide. So the first way that we learned to divide is an array. Okay? An array just kind of models what that division looks like. So we learned this in 3rd grade. If I have 20 and I'm dividing it by 4, so I have 20 things, and I'm splitting them into 4 groups. And I like to make my arrays more like this. Some people do circles. I like to do this, just kind of keeps them organized. And in 3rd grade, we had you guys do this, which was I took 20 and I'm like going to go 1, 2, 3, 4, essentially splitting that 20 up piece by piece. 5, 6, 7, 8. 9, 10, 11, 12, and I keep counting, 13, 14, 15, 16, 17, 18, 19, 20. And this was definitely a pictorial way to divide. And I can even use an array for bigger numbers. So if I had 2,754 and I'm dividing it by 9, I'm going to use 9 groups. So I'm going to make these a little bit bigger. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 1, 2, 3, 4, 5, 6, 7, 8. And I'll move my paper up a little bit so you can see that I have my 9 groups. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now over here on the side, I'm just going to keep track of my total, and I'm going to subtract from my total how much I put in each one of the groups, because I'm not going to draw one individual dot for each one of 2,754. We're going to take equal groups out of it. So I can't do 1,000 because I have 2,000 and I'm dividing by 9. So I can't, I'd have to have 9,000 to do that. So then I can think of hundreds. So I'm going to take out 100 for each. 1, 2, I'm just going to write the number. 5, 6, 7, 8, 9. So that's taking away 900. 17 minus 9 is 8, and then I've got my regrouped 1. So I've got 1854 left. Well, of course, I can do another 100. 100, 100, 100. So then I'm taking out another 900. 4, 5, I've got to regroup. So 18 minus 9 is 9. So I have 954 left from my total. So of course I can do another, I can take out another 900, so I'm going to put 100 in each group. And certainly you can do this. It just takes a little bit of time to draw it all out and to subtract it all out. So I'm taking out 100. So then I'm left with 54. So some people will think, 54 divided by 9, I already know that. Some people wouldn't have that. So I know I can't do 10 because I'd have to have 90 and I only have 54. So I can think of groups of 5. So because I can do 5, 10, 15, 20, 25, 30, 35, 40, 45. So I can take off 45. So I have 9 left over, which means I can give 1 to each one of these. So my answer would be this all together, which is 100 plus 100 plus 100, 300, plus 5 plus 1, which is 6. So my answer is 306. Because remember, your quotient should be what's in each group. So I have 306 in each group. Okay, so that's using an array. Another way to divide is using the area model. So we're going to just put area model. If you notice in my notes, I didn't write area model up here. I left it down here because I'm not titling this area model. This is part of my notes for what I am taking in my notebook. Okay, so with the area model, if you remember, so I'm going to first draw a big box or rectangle. Shouldn't say box, should say rectangle. And when we multiply, we split up the numbers using place value, and we draw lines, and we multiply within those boxes, and we find the areas of each one of the little boxes for our partial products. We're kind of doing the same thing here. The only thing is I know my total, and I'm going to still use the same problem, 2,754 divided by 9. My total, though, is what's right in here. So I'm going to mark that kind of small. That's in here. I'm not labeling it outside because it's not the length of one of the sides. It's how much is in here. I have 2,754 small little blocks, excuse me, inside my rectangle. And I know one of my sides is 9. I'm trying to figure out what the other side is. So just like I do with multiplication, and I can make partial products, I can still kind of section this up into the areas, and I can just break it up into pieces. So I can, there's several ways that you can break it up, thinking the same way of, I can't have 1,000. This line cannot be 1,000 because the area is under 9,000. So I have hundreds. And let me think. I have 27 hundreds. Thinking about place value, 700s, but that 2,000, that becomes hundreds, and I'm regrouping that together. So I've got 27 hundreds in this. 27 divided by 9 is 3. But this isn't 27. This is 2,700. So 2,700 divided by 9 is, and I can put that over here, 2,700 divided by 9. If I know 27 divided by 9 is 3, 2,700 divided by 9 would be 3. And thinking of those zeros that we did last chapter, 100 got the same. Once I divide this main piece, I've got my zeros. You can see that pattern, which you should have, that's some, like I said, this is a review from last year. So I can have this area 2,700 because this is 300. Which and I can kind of use this on the outside. Here's my total area. And I'm going to take away 2,700. So now I have an area of 54 left over. So I know this is not to scale because this doesn't look quite like it should. But I have 50, so the area over here is 54. And if I think about that, 54 divided by 9, if you remember your multiples of 9, is 6. 6 times 9 is 54. So if I did 9 times 6, I should get that area just like we did with partial products, except for we're dividing and finding one of these missing sides. So minus 54. I have nothing left. I'm going to add that together. So my quotient is 306. So that's kind of using area model to divide. Next up, we have partial quotient. And I know I'm using a piece of paper for each. It's just because of my camera. But on your notes, you don't have to use a piece of paper for each. We have partial quotients. Now this I know was a favorite last year to use for division. So with this one, we are going to basically set it up like we would think, and so we're still going to use the same problem, 2,754 divided by 9. So I'm going to give myself some space because I do this a little bit differently. So I've got 2,754 divided by 9. And I'm also going to show you the area model over here so you can kind of see. So I've got 9 here, I'm taking that 2,754, and I'm going to have that total so that you can see that we're taking away that total and breaking it up just a little bit differently. Now if you did the big 7, which it would look like this, and you put your partial quotients on the side and out, you can do that. I do mine a little differently just so you can see the place value, and it just kind of transitions to the standard algorithm a little bit easier when you have to use it for 6th grade. So I don't have 9, I can't do 1,000, so I can do hundreds. So on this one I'm going to just take out 100 at a time. So I'm going to, this is going to be 100. 100 times 9 is 900, right? So I'm going to put 100 in each one of my groups. So if I want to think about what I have left over, I have to see how much total is in each one of those groups altogether. 100 times 9 is 900. So I'm going to take away 900, and I'm left with 4, 5, I got to regroup. 17 minus 9 is 8. Don't forget that one. So I've got 1,854 left. I can do another 100 in each group. So another 100 in each group. So that would be a total area of 900 for that section. So 100 times 9 is 900. See how much area I have left over. 4, 5, regroup. 18 minus 9 is 9. I can do another 100. Now I know last year you did a lot of 10s. I saw a lot of people trying to do 10s, but you really want to start getting closer to where you're not doing 800 million partial quotients. So we want to try to, really think about what we can use. So I can do another 100. 100 times 9 is 900, so I'm taking away 900 again. So 900, I'm left with 54. Now I'm going to be the advanced student and say, well, hey, 54 divided by 9 is 6. So that area is going to be 54. I'm going to put that 6 up here. 6 times 9 is 54. I have no remainder. I'm going to add up my partial quotients, 306. Now you do not have to do the area model with that. It just shows you how much that I'm taking, that's the reason why I'm taking out that total area, that partial area that I'm using, so I see what area I have left over to try to put into the groups. If that makes sense. Okay. Next method that we're going to use is the distributive method. With the distributive method, we're taking our division problem and we are pulling this dividend apart pretty much. So we're putting it into groups that we can divide easily by 9. So, and then we're adding those pieces together. So if I think about multiples of 9, obviously 2700, I can do 2700 divided by 9, and then I'd have 54 left. These two pieces should be able to be added together to equal that. If you use the distributive property correctly, that's how that should work. So I'll show you in a little different way here in a minute, so you can see that it doesn't matter how many pieces I break it up into, as long as all the pieces that I have broken it into add up, the total pieces add up to my total dividend. So 2,700 divided by 9, 27 divided by 9 is 3, 2,700 divided by 9, which would be 300, and then we're adding 54 divided by 9, which is 6. So my answer is 306. Okay, just to show you that I can split it up even more. So if I'm doing groups, so say you couldn't think of it as 2,700 divided by 9, and I could think of it as 900. So you might have to do a running total so you can see what you have left over. So 900 divided by 9, because the total should equal 2,754. Plus, well, if I do that, then I have 1,854. I still can do 900 divided by 9. And that was horrible math there. Don't do it like that. 4, 5, regroup. 18 minus 9 is 900. So I still can do another 900 divided by 9 minus 900. 54 plus 54 divided by 9. So all of these here, 900 plus 900 plus 900 plus 54 equals 2,754 minus 54. Okay, so this would be 100 plus 100 plus 900 divided by 9 is 100 plus 54 divided by 9 is 6. So this would be 306, just so that you can see it again. And last but not least is the standard algorithm. Now I will show you a different way to do the standard algorithm, a way that I used in my classroom last year, which really helped some students kind of see it a little bit better. But for today, I'm just going to show you the regular way. So this would be the way your parents know. So we're not going to show them the new math just yet. We have 2,754 divided by 9. I cannot do 2 divided by 9 because we're really just dividing by the digit. Just like with the standard algorithm for math, for multiplication, it was multiplying by the digit. Dividing with the standard algorithm is the same thing. We're dividing by the digit. So you're doing 2 divided by 9. Can't do that. So then I'm going to look at 27. 27 divided by 9 is 3. 3 times 9 is 27. I'm going to subtract that. That's 0. And I'm going to bring down the next digit. 5 divided by 9, cannot do that. So that's going to be 0. 0 times 9 is 0. So I'm going to subtract 0. Got 5 left over. Bring down my 4. 54 divided by 9 is 6. 6 times 9 is 54. And then I have 0. And it goes with the kind of mnemonic, divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So there's not really, people have different things for these letters, but divide, multiply, subtract, bring down, because you're dividing by the digit, then you're multiplying how much total you take away, you subtract to see what you have left over, and bring down that next digit. Then you divide, multiply, subtract, bring down until you have your remainder. And of course, this time we have a remainder of 0. So make sure your notes